Hey, math friends. So, I want to review today because you guys are going to take a quiz on constant of proportionality and proportional relationships. So, our goals for today, you want to make sure that you can find constant of proportionality in words, equations, a table, and a graph. And you also want to know if those four representations are proportional or not. So, let's review really quick what we did in a previous lesson. So, the big ideas that you need to remember: a proportional relationship is a ratio with the same scale factor, so a comparison of ratios with the same scale factor. A proportional graph is in the format of going through the origin and it is a straight line. And we can find COP by looking on that graph where the x value is 1, whatever the y value is. So our y value is our COP. A proportional equation is in the format of y equals k times x. And it doesn't have to be y and x, it can be any variables, but the k is always our COP and it's always a number. A proportional table, every row will multiply by the same number to go from the left to the right side. So for this one, every number is multiplied by 4 to go from A to B, and 4 is then our COP, or the number you're multiplying by within that table. And also, just to remind you, constant of proportionality is the same thing as the unit rate for any of these representations. And unit rate, again, is the amount for 1. So let's review this in some graphs. For number 1 here, we want to know which situation is best described by the graph shown. So let's look at A. Allison purchases lemons for 75 cents each. Okay, so this is looking for us to find how much each thing is. Well, if I want to know unit rate, that's the COP for that graph. So I'm going to look right here for the amount that is 1 and see what y value matches up with that. So this actual line here is 3, so it's got to be less than 3, okay? And it's less than half of 3, so I'm thinking that it's likely to be less than $1.50. So Allison purchases lemons for 75 cents each. Okay, that's possible. Sophia buys 12 packs of soda for $1.75 each. I'm thinking not. C. Jacob buys packs of gum for $1.50 each. Possibly. D. Garrett buys limes for $1.20 each. Possibly. So 3 of these are possible. So we need to go to a point that actually crosses the graph. So I'm going to look at this point here. 4, 3. So if I was going to figure out this COP, or the amount for 1, I'm going to say 4 times what number gives me 3. I'm going to use inverse operations for this. So I'm going to divide by 4 instead of multiplying by 4, and I get 3/4. A, C, or D, which of those decimals is the equivalent of 3/4 as a fraction? It's going to be A. Allison purchases lemons for 75 cents each. All right? So let's look at number 2. Find the unit rate in the graph below. And remember, unit rate is the amount for 1. So I'm going to look at 1 on the x and see where it crosses on the y. So I've got 9 miles per hour. Well, it's definitely between 3 and 6, so no. 4.5 miles per hour, possibly. 3 miles per hour, no. 1.5 miles per hour, no. So we don't have to find a point on this graph. We can say that B is correct. How many dozen cupcakes can Sam make in 1 hour? Well, remember, 1 is our unit rate, or our COP. So we're finding that unit rate, COP again. So I'm going to go up and then over, and that stops at 4. So 4 dozen cupcakes. So remember, for a proportional graph, you need to make sure that it is a straight line and that it goes through the origin. Those are the only 2 criteria. Then if you are asked about unit rate, or if you're asked about the amount for 1, or if you're asked to find the constant of proportionality, that's all the same thing. Look at where the x value, the horizontal, is 1, and then go up from there. And if it's not perfect like it was in this past problem, this one here, you can find a point on that graph and then find the scale factor or unit rate from that. So now let's talk about proportional tables. The question is, do these graphs represent a proportional relationship? Let's look at the first table. I want to know if I'm multiplying by the same number in every row. So let's try it out. 1 times something gives me 3. What am I multiplying by? I'm multiplying by 3. Well, let's try it. 4 times something gives me 9. Is it 3? No, that would give us 12. We can automatically know that this first table is not proportional because I'm not multiplying by the same number. Let's look at the second table. 3 times something gives me 18. I think it's 6. 3 times 6. 5 times something gives me 30. If I didn't know this, I could write this equation and I could work backwards. I could do inverse operations. Instead of multiplying by 5, I could do 30 divided by 5, and I would get 6. Multiplying by 6 there. 7 times something is 42. Well, pretty sure it's 6. 9 times something is 54. It's 6 again. Am I multiplying by the same number for every single row? Yes. So, this table is proportional. Let's look at these other two examples that we have. For number 4, a florist uses 200 lilies to make 8 identical flower arrangements. How many lilies would the florist use to create 6 identical arrangements? There's 2 ways you could do this. You could find the unit rate. So 200 lilies, 8 arrangements. I want to know how many lilies per arrangement. So 200 divided by 8, that's going to give me 24. So I know there's 24 lilies per 1 arrangement, okay? So if I've got 1 arrangement, 24 lilies, I want to know 6 arrangements. Well, if I do 24 times 6, I get 1,444. So I would need 144. Now, I want to show you another way you could do this. If I want to know a proportion that I could use, I'm going to keep this same thing here. 200 lilies, 8 arrangements. Do you see how I'm writing my units here? Lilies and arrangements. I want to keep that throughout. And I'm going to use, I don't know how many lilies for 6 arrangements. Again, my units are the same top and bottom. I could cross multiply and then divide to find my answer. But the question may be, what proportion could you use to solve this? For number 8 over here, the table shows the relationship between the number of miles traveled and the number of gallons of gas used. Why? Which of these is an equation that best represents that relationship? If you look at all the equations, they all represent a proportional relationship, except for one. Remember, a proportional relationship is y equals k times x, so that I have 2 variables and then a constant or a number. A represents that, B is that format, but look at C. This has 2 constants or 2 numbers, so that's not going to work. D is also a representation of a proportional equation. So now we need to find the COP, or our K value. Well, how do we do that? If we have a table, I know from X to Y what I am multiplying by. So 35 times something is equal to 1. Well, I know that 1 times 35 is 35, but 35 times something gives me 1. If I were to do it this way, I'm going to get a fraction. So I'm going to use the inverse operation, and I'm going to do 1 divided by 35, and that's just a fraction, so 1/35. So that would be my COP. A is not correct because that would be if I was going from y to x. B looks like it represents our equation because 1/35 is our COP. D, not sure where that comes from, so we're going to mark that one out. So make sure when you have a table, even though the numbers are going to get smaller sometimes, you make sure that you set it up with this format. X times something gives me Y. Okay? So you're going to take your quiz today. Good luck on that. Be sure to show your work, just like I did. If it's a graph one, make sure you write on it and show me how you got your answer. If it's a table or an equation or words, make sure that you show how you got those answers. You're going to show your work on notebook paper, and then you will turn that in. Good luck, guys.